But we do have some interesting videos for you guys all. It's not funny or anything. They're just very, very interesting. As always, boys, let's get into it.
There's only one way to see the stars while the sun is out, and that's during a total solar eclipse. You have to be at the right place at the right time, under a clear sky, standing somewhere along the narrow path where the moon aligns perfectly between the sun and the earth. When the moon passes in front of the sun's disk, it darkens the sky just enough for distant stars to become visible. There have been many photos of total solar eclipses, but this one is special. It helped prove a radical idea that redefined gravity and turned Albert Einstein into a celebrity. Because the stars in this photo aren't where they're supposed to be. Isaac Newton laid the foundation for understanding the physical universe in the Principia, published in 1687. In it, he defined gravity as a force of attraction that draws massive objects, like stars and planets, toward each other and keeps them in orbit. And for more than 200 years, gravity was defined this way, as an attracting force. But Albert Einstein saw gravity as something completely different. According to his theory of general relativity, which he published in 1915, gravity isn't a force between objects in space. It's the influence of objects on the shape of space itself. According to Einstein, massive objects like the sun bend the space around them. So when a smaller object moves in a straight line along this space, it gets diverted because of the curve caused by the mass of the larger object. That puts one object in orbit around the other. And if Einstein was right, then the same curve would divert the path of light as well. Meaning, if you observe distant stars through a telescope on Earth while the sun is in front of them, their light, deflected by the sun's gravity, would make them appear slightly out of position. It was a revolutionary idea, but there was a big conflict keeping Einstein from testing it. The world was at war. Einstein lived in Germany at the time, but his work landed in the hands of a British astrophysicist, Arthur Eddington. Even though they were on opposing sides of the war, Eddington, along with astronomer Frank Dyson, set out to test the theory. They would photograph a total solar eclipse. They needed to compare the position of a cluster of stars in the night sky with a photograph of the same stars during an eclipse. If the stars' apparent positions had shifted, it would prove that starlight was traveling through space curved by the sun's gravity. The May 1919 eclipse was the ideal one for this experiment. The sun would be in front of a very dense cluster of stars, the Hyades, and that meant multiple bright stars would be visible during the eclipse. Planning began in 1917, and a couple of years later, 2 expeditions departed England. One, led by Eddington, went to the island of Principe in West Africa, and the other headed to Sorable, Brazil. 2 locations that were in the path of the eclipse and had favorable climates. Each group traveled with powerful photographic telescopes that could record detailed photos of space onto glass plates. Photographing the eclipse that May required transporting and then carefully assembling them in the field, with the plates tilted 45 degrees on one of the telescopes to include as many bright stars as possible. And this was the result.
This
is one of the few successful plates from the 1919 expeditions.
Yo, Joshua, appreciate you coming in here and hanging out once again, brother. Take it easy and stay prestigious, baby. Exclamation mark gamble all, boys. It's called gravitational lensing. Yo, honestly, dude, I have no clue about any of this stuff. Literally not a single soul about any of this. But it's pretty interesting.
It came from Brazil. It shows the eclipse during totality, the sun's corona bursting forth, and the rarely seen solar prominence. Most importantly, bright stars of the Hyades. Back in England, Eddington compared the position of the stars from the eclipse plate with another of the night sky, using a machine that can take measurements within photos at the microscopic level. The comparison revealed that the stars had shifted during the eclipse by roughly the amount that Einstein predicted. According to Newton's calculations, starlight should bend near the sun too, but if Einstein was right, that deviation would be twice what Newton predicted. Eddington's results showed that the deflection of the stars came closer to Einstein's calculation than Newton's. It wasn't a perfect match, but it was close enough to validate the theory of general relativity and completely shift our understanding of the universe. The success of the experiment was first announced in the Times of London on November 7th, 1919, almost a year to the day after the end of World War I. An Englishman had gone to great lengths to prove the ideas of a German, and the news that space is warped by the planets and stars excited the world. Einstein, who before this moment was only known in the physics world, essentially became a celebrity overnight. He remained an international pop culture icon for the rest of his life, and a favorite subject of press photographers. Observing eclipses continued to be one way of testing general relativity for decades to come, with more sophisticated equipment repeatedly confirming the accuracy of Einstein's theory. General relativity allowed physicists to begin to understand advanced concepts about the universe, like black holes, which ultimately led to this, the first photograph of a black hole, taken in 2019, a century after Eddington first proved Einstein's theory with a photo, and completely changed our definition of gravity. There may be only one way to see distant stars in the middle of the day, but there are endless ways to listen to music. One of those ways...
Dude, that was dope. That was really cool, man. That was really, really cool. I love these videos, man. They're super, like, educational, and they're actually really, really interesting. I have no clue, to be honest with you guys, what's going on, but, like, at the end of the day, I feel like I learned something while just hanging out and just watching with you guys. It happens due to the bending of light when it is passing through the sun's curvature of space and time. Or just space is time. That wasn't scary though. It's not scary now. Yeah, Lucas. To get rid of everyone's like nightmares, because everyone got scared of the videos I played. We're gonna watch some cool videos. And yo, Limes, appreciate you for hanging out tonight. As always, brother, you hang out for a long time tonight, bro. I appreciate that. Congratulations on the gifted sub. Hell yeah, brother. One time for the one time, dude. That's crazy, man. It's honestly crazy, boys. I feel like I've been putting in a lot of work for the stream and just the content in general, but I really haven't. But I appreciate all the support, Aaron, Inmate, you know what I'm saying? Literally everyone donating and just hanging out, the homie Rob, Future, literally just everyone in general, man. Thank you guys for like all the love you guys have been showing me recently. I appreciate you for that. Space-time is basically a plane of sheet, just like a trampoline. So it curves. So that's what they were talking about when the sun was doing like that weird little thing, right? That weird little like bending thing right here. That's dope. Yeah, yeah. I'm going to have nightmares now. All this science talk makes me think of school, and that's scarier than anything. Dude, that's honestly probably one of the funniest comments I've seen all night. Boys, everyone give a round of applause to the homie Preyas. Also, Preyas, if you don't have, I think you're on your phone, but if you don't have Better TTV, boys, !BTTV in the chat, download the Better TTV web browser thingy, and it makes Twitch on your computer 10 times doper, dude. And what's up, Craft? That's why it's getting stretched due to the sun's mass and the gravitational pull within the solar system. That's cool. That's cool. That's super cool, dude. That's really cool. All right, do you guys want one more of these? Or do we want daily dose of internet? What do you guys want? I think this is really cool. Honestly, dude, let's just watch one more.
On April 4th, 2017, a privileged group of telescopes on mountains across the planet switched on at the same time. For the next week, they danced in unison, collecting radio waves dispatched from the center of our Milky Way galaxy and from the galaxy M87. Together, they make up the Event Horizon Telescope, a global project to capture the first ever picture of a black hole. That's right, ever since physicists first conceived of black holes centuries ago. Every image of one from our textbooks and our space agencies, they're all illustrations. Until now.
We are delighted to be able to report to you today that we have seen what we thought was unseeable.
For centuries, physicists have theorized that an object with enough mass and density could trap even light in its gravitational field. Just as you have to travel faster to leave Earth than you do to leave the moon, there could be a place where you'd have to travel faster than the speed of light to escape, and nothing moves faster than light. The math from Einstein's theory of general relativity describes an area completely invisible to us within a boundary called the event horizon. And at the center of that black hole is a singularity, a point of infinite density, which is where physics as we know it breaks down.
They showed up in the math long ago and they kept reappearing and they sort of persistently would not go away. But Einstein always
That's
thought
the
that there must be
homie.
some physical mechanism that prevents stars from collapsing to an infinitely small point, which is actually pretty reasonable. I mean, because it sounds insane.
Eventually, scientists began to see things that only made sense if black holes were real, like the orbits of these stars around the center of the Milky Way galaxy.
You see these stars just slingshotting around an invisible point. And a black hole is the most likely explanation for putting that amount of mass in that small space for something that's completely dark.
Bro, that's a galaxy.
We can also see the glowing material that spirals around black holes. Friction heats this matter up tens of millions of degrees, and anything that hot emits X-rays that we can detect with telescopes that orbit above Earth's atmosphere. This is a pair of galaxies that pass through each other. There are at least 9 suspected black holes here, but you can only see them when you look at the X-ray layer. These dots are X-ray sources linked to suspected supermassive black holes at the center of galaxies 3 to 10 billion light years away. And that's just from this small patch of sky.
Yo!
Some supermassive black
There's no
holes
way
also
that's the
feature
scale.
gigantic jets of particles, seen here in radio wave data from the galaxy M87, which has a much bigger black hole than the one in the center of the Milky Way.
Thank you for the follow, brother.
No other known source of energy could power these things.
Dude, that's so
And nothing we know
small.
of besides 2 black holes colliding could have produced the gravitational waves we detected in 2015. Scientists think there are black holes, large and small, all over the universe. We can see their fingerprints, but we didn't have the mugshot.
Dude, that's just crazy.
Directly imaging a black hole has been impossible because they're either too small, too far away, or both. Sagittarius A star, the black hole at the center of our galaxy, has the mass of 4 million suns, but it would fit inside the orbit of Mercury. Imaging it from Earth is like taking a picture of a DVD on the surface of the moon, with huge clouds of dust and gas in between.
So many things had to go right for this image to exist. So the first thing that has to happen is there has to be some slice of light that travels all the way from the edge of the black hole without getting knocked off course or absorbed by any of the gas or anything in between. And then it also has to make it through the Earth's atmosphere, which a lot of frequencies of light don't.
They landed on a wavelength of 1.3 millimeters at the high-frequency end of the radio spectrum. With that wavelength and with 8 observatories across the world, the Event Horizon Telescope had a chance at seeing a black hole, as long as the weather cooperated.
You have to have clear weather in all of those places at a time when the Earth is oriented in such a way that all of those telescopes can see the black hole simultaneously. They can really only observe once a year.
There was so much data
Wow.
involved that it had to be flown on airplanes. They waited 6 months for the hard drives to arrive from the South Pole, which closes during wintertime. This multi-telescope method is called Very Long Baseline Interferometry. It correlates time-stamped data from distant telescopes to boost the signal and quiet the noise. Each pairing of telescopes contributes a piece of the puzzle. But the image doesn't just pop out after that. They had 4 groups working for months to generate the image that best represents the data.
Each group was working individually and like in isolation from the other groups, working with the same data to see that each group came up with the same image or not.
Here it is.
And the result of all that work is this.
Damn.
The bright parts are the matter and light swirling around the black hole, and it's brighter on the side that's moving toward us. And the dark part is the black hole's shadow, which includes the event horizon plus a region where light could escape but doesn't. The size and shape of the shadow appear to confirm the theory of general relativity.
Today, general relativity has passed another crucial test, this one spanning from horizons to the stars.
Humanity's first image of a black hole isn't crisp and beautiful like the illustrations or the movie Interstellar. It's better.
The picture we see this week is made of scraps and bits of light that's been traveling across the universe and collected by these, aluminum dishes on top of mountaintops and then combined in a supercomputer to make this image. So that's why it's real.
Oh my God, man.
mind in a supercomputer.
Bro. Like, that's crazy, man. That's just insane. I know y'all are talking about, learning and it's science and all that's boring, but like, bro, it's pretty interesting at the end of the day, man. Like, who knows, bro? Hopefully in like 100 years we could go to Mars, you know what I'm saying? Like everyone, you know what I'm saying? Like we could get a goddamn plane ticket. I'm not talking about no astronauts, super scientists. I'm talking about some wealthy people can just book a plane ticket to Mars, man. And it's just crazy to see like how much science is like grown, bro. Like 100 years ago, this doesn't look like anything, man. It's crazy.